Okay, so in this video, we're going to implement the binary search version of our solution in code. Okay, so this is the solution. So if you haven't tried to implement this yourself yet, I would recommend doing so because the pseudocode is pretty much exactly the same as the real code. So you should be able to take that and implement it directly. And if you can't, that suggests that you might have an issue. Okay. So we'll begin by defining our better search function. This takes in a matrix A, and it's almost the same as before. The whole setup is the same, and the basic structure is the same. So basically just looping through each row, counting the number of ones in each row. Okay, so we'll keep a counter for the maximum number of ones that we've found in a row so far. And we'll also keep track of which row was the best so far. Okay, and then we're going to loop through each row using enumerate so that we get the row index as well. And then inside the loop, so now instead of just looping through each column one at a time, so for C in row, so instead of doing that, we're just going to find the index of the first one, and we'll assume that we have some function called binary search that finds this index. Okay, and so this will only proceed if we actually find that one. Otherwise, there's nothing to do. There are no ones, and so we just skip that row. Okay, so only if the index is greater than or equal to 0, otherwise we'd return -1. Then from this, we can calculate the number of ones in that row. Okay, so how can we do that? So that's the number of ones equals the length of the row minus the index of the first one. Okay, and you might want to draw that out on paper to convince yourself that this formula works. But for the purpose of this lecture, we'll assume that it does. Okay, so the next step is the same as before. Now we just check if the number of ones in this row is bigger than the maximum number of ones in a row we've found so far. And if that's true, then we set max ones to the current num ones, and we set best row to I. And then at the end of this loop, we return best row. Okay, so we'll write that, but you see that binary search is not yet defined, so that's the next thing we're going to have to do. Okay, so let's define a function called binary search, and this is going to take in a row, which is an array. So we'll use a lowercase a to signal that it's a one-dimensional array, as opposed to a big letter A, which corresponds to a two-dimensional array. And then inside this function, we're going to define our left index and our right index as so. And we're going to loop until this is no longer true. Okay, so in the theory lecture, we used some formula for the middle index, something like left plus right minus left divided by 2, but a simpler way to do that, to find the middle of two numbers, is just to take the average, right? So that's right plus left divided by 2, and then we just check. So this is a little bit different from traditional binary search because we're not just looking for a value, we're looking for the value and its neighbor to the left. Okay, we're saying if a mid is equal to 1, and so these are the two cases we need to consider. Either we are all the way at the left already, so mid is equal to 0, so we don't need to look to the left, or a mid minus 1, the element to the left, is 0. And in either of those cases, we have found the leftmost one, so we return mid. Okay. Otherwise, we'll check if a mid is equal to 0, which means we haven't yet found a 1, which means we need to search to the right. Okay, so L equals mid plus 1. And the case that's left is, so not this, so that means we do have a 1, but this part is not true. Okay, so this means that we found a 1, but there are still more 1s to the left, so we need to look left. So we say right is equal to mid minus 1. Okay, and the final case is the not found case, and we just return minus 1. So let's run that. And then we can copy our tests from above. And you may want to write more tests on your own, by the way, just to see if this works properly on more cases. So let's try this. Okay, so that works. And let's try the other array where there's nothing in it. Well, no 1s at least. Okay, and that's minus 1 again. And you actually could also try a completely empty matrix, a 0 by 0 matrix. You know what, let's just do that for fun. A equals... Is that gonna work? Okay, so that works as well.